Hello students, let us continue with chapter 10, circles. We'll take a look at a new concept, angles subtended by a chord at any point. So first of all, what do you mean by subtended? Let's say I take any 2 points P and Q and I join this line segment PQ. Okay, then I take any other point R that does not lie on this segment PQ. Let's say I am taking this point R over here. So PQ and R are non-collinear points. And when I join R to P and R to Q, then this angle so formed, that is angle PRQ, is the angle subtended by the line segment PQ. Similarly, now if I take a circle, so I have my circle, I mark 2 points P, Q and I draw this chord out here. O is, let's say, the center of the circle. So when I join O to P and O to Q, I have angle POQ subtended by chord PQ, and this angle is subtended at the center. So angle POQ is subtended at the center by chord PQ. If I take a point out here, let's say R, and I join R to P and R to Q, if you notice that PQ is the chord out here, but this section here is the minor arc and this section here is the major arc. PRQ is your major arc. So angle PRQ, so this is one angle. So angle PRQ is the angle subtended by PQ on the major arc. So angle PRQ is subtended at the major arc by chord PQ. Similarly, if I take a point M and I join PM and QM, then what is angle PMQ? Angle PMQ, it is subtended at the minor arc by segment PQ. So basically, what is the subtending? When you take any line segment and you take any third non-collinear point and you connect the endpoints of this line segment to this non-collinear point, then the angle so formed is subtended by the line segment. So here we have angle POQ subtended at the center, angle PRQ subtended by PQ on the major arc, and angle PMQ subtended on the minor arc by segment PQ. So this was about chords subtended at different points, angles subtended at different points. We learned about angles subtended at the center, the major arc and minor arc. What about I have a circle with my center O and I take any equal chords. So let's say PQ, then RS and MN are equal chords. So all these chords are equal in length, and I subtend angles at center using these 3 chords. When you go and measure this using a protractor, you will notice that this angle is equal to this angle is equal to this angle. So angle 1 is equal to angle 2 is equal to angle 3. So what can we say about the angle subtended by equal chords at the center? That the angles subtended at the center by equal chords are equal, and for this we have our theorem 10.1. So let's write down the statement and we will go about proving this. So my theorem 10.1, I'll say angles subtended at the center by equal chords are equal. So how will we prove this? I'll say proof, and I'll draw my circle first. So this is going to be my center P, let's say O. Then I will take two equal chords. Such that, so I'll call this PQ and RS. Okay, I need to prove that these two angles are equal to each other. So how will I prove that? Now first of all, if you notice your angle POQ and your triangle POQ and triangle ROS, what do you notice? That OP is equal to OR because they are the radii of the circle. Also OQ is equal to OS, again they are the radii of the circle, and also it's been given that PQ is equal to RS. Why? It's already been given that angle subtended by the center by equal chords. So equal chords means PQ is equal to RS. Therefore POQ triangle, POQ is congruent to triangle ROS by the SSS test of congruence. That is side test of congruence. Therefore what can I say? That angle POQ is equal to angle ROS by the property corresponding parts of congruent triangles property. So let's write the proof now. So I'll say given, let the circle alongside have center O, have its center at O. Let PQ is equal to RS be two chords of the circle. To prove that angle POQ is equal to angle ROS. So I'll say proof. In triangle POQ and triangle ROS, I have PO is equal to RO, and also I have QO is equal to SO. Both are radii of circle. Correct? And also we have PQ is equal to RS. This is given. Right? Therefore, triangle POQ is congruent to triangle ROS by side test of congruence or SSS test of congruence. Therefore, angle POQ is equal to angle ROS by corresponding parts of congruent triangles or CPCT. Hence, we have proved that angles subtended at the center by equal chords are equal. So is the converse true? So what will the converse be? Let's write the statement. This would be Theorem 10.2. So Theorem 10.2 is the converse, that if the angles subtended at the center by two chords are equal, then the chords are equal. So what does this mean? If I have a circle with center O such that I have angle subtended at the center by two chords. So my chords are PQ and RS, right? It's been given that this angle is equal to this angle, that is POQ is equal to ROS. I need to prove that RS is equal to PQ or PQ is equal to RS. If you can see, we can quickly prove these two triangles congruent to each other. Which two triangles congruent to each other? POQ and ROS by the side angle side test of congruence. Because see, these two sides are equal to each other because they are the radii. Again, these two sides are equal to each other because they are the radii, and you have the angle in between which is equal. This has already been given. Therefore, the two triangles are congruent to each other by the side angle side test of congruence. Therefore, I can say that PQ is equal to RS by corresponding pair of congruent triangles. So, let us go ahead and write the proof, and therefore, we can say the converse is also true for angles subtended by the chord of the circle. So, I will say proof, let O be the center of the circle given alongside. So, in the proof this is given. I will say proof here. Okay. Then angle, let PQ and RS be two chords subtending angles POQ and ROS respectively at O, and also angle POQ is equal to angle ROS. So, what do we need to prove? We need to prove that PQ is equal to RS. So, I will say proof, in triangle POQ and triangle ROS, what do I have? Side PQ, side PO is equal to RO, side QO is equal to side SO. Why? Because they are the radii of my circle. And from here, what do I get? I have POQ is equal to ROS. Angle POQ is equal to angle ROS. This is given. Therefore, triangle POQ is congruent to triangle ROS by the side angle side test of congruence. Therefore, what can I say? Therefore, PQ is equal to RS by corresponding pair of congruent triangles. Hence, we can prove the statement of theorem 10.2, which states that if the angles subtended at the center by two chords are equal, then the two chords are equal. So, just make sure that this statement is clear to you. This statement means that if the angles subtended at the center by two chords are equal, this means the angles subtended are equal by, so these angles are subtended by the two chords. So, you need to prove that the two chords are equal. So, we learnt about two theorems, 10.1 and 10.2, both related to angles subtended by chords at a point, and now we took into consideration angles subtended by chords at the center. So, theorem 10.1 and 10.2 are related to angles subtended by chords at the center. We will take a look at the sums based on this in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.